Hi, everybody. And if you responded in your head, hi, Dr. Nick, you're my kind of person. Welcome to Building Performant Cross-Platform Mobile Applications with React Native. I'm Mark Masterson. I'm a Senior Applications Engineer at Fusion Risk Management. Fusion Risk Management is a business continuity management system built on Salesforce.com. So it's all native. If you want to know more about business continuity, you can hit up their website. It's really all about how you're going to respond to either crises that hit your business or IT disaster recovery, how you respond to like that kind of emergency and how you recover your business from that. In terms of myself, I've been developing on Salesforce.com for a long time. I go back to Visualforce before we had remote actions, just using Apex tags. I've been developing a long time. And some of the things I like to do in my spare time, I'm a blue belt in Brazilian Jiu-Jitsu. I like to play guitar. I've been playing for a long time and I should be a lot better than I am, but it's one of my favorite things to do is just to make noise on the guitar. And I love 80s movies, and I promised I wouldn't make any Big Trouble in Little China jokes, but you know what old Jack Burton says? No laughter this year. Okay. I got one person to laugh 2 years ago. So, who here is using React today? A couple people? So, just so we're all on the same page, I'm going to do a little overview of React, because that's the basis of React Native. Then I'll do a little overview of React Native, an overview of the Salesforce Mobile SDK, and how that interacts with React Native, and then I'll go through a little demo and kind of show you how it all ties together. So React is a JavaScript-based view library built by Facebook. It's component-based, so it's a lot like Lightning Component Framework that you use with Salesforce. The whole idea is you build up little Lego blocks of functionality, and then you assemble those Lego blocks into your application. That's the way I like to think of it. So you're not building just this giant HTML page with a script tag that does a bunch of stuff and jQuery, querying all your different DOM elements and building your web applications that way. One of the unique things about React is that it uses a thing called JSX. This allows you to use XML tags within JavaScript. So a lot of the other component-based libraries that exist, like Lightning Component Framework, Vue, Angular, they have these idea of templates. Like in Lightning Component, you have the .cmp file. That's your template that you're using. With React, you don't need that template file because you're able to put the XML directly in your JavaScript. And one of the other keys is that there's just this render method. And that render method tells the React engine what to display on the screen. So that's really the key fundamental part of it. Here's a demonstration of what a really basic React component looks like. We have ES6 syntax that we're using here. So this is JavaScript. We're creating a class. We're extending React.component. That's what tells the React engine that this will have a render method. And this, you can see here within the return, we have the JSX. So we're returning a div out with hello world. Another fundamental part of React is the idea of props. This is what allows you to pass information from a React component into another React component. So here we have a little example of a greeting. So instead of just saying hello world statically, we're using this.props.name. And the way this is implemented is we have another React component down here, and we're using this React component and passing the name prop down here. So instead of saying hello world, this top component would now, in this implementation, say hello Dreamforce. Two more fundamental concepts of React. Each React component has this idea of state. So this allows you to add a lot of interactivity into your React components. So each React component has a state. You can set it up in the constructor. So here's an example of a counter component. And we're setting a counter state to 0. Then in the render method, we have we're displaying the current state, which would start out as 0. Then we have an increment button and a decrement button. And then within those on-click handlers, we're manipulating the state, we're incrementing or decrementing. I'll pop into a quick demo of what some of this looks like in the simulator thing. Okay, so here we have the iOS app. This is an example app. I have this code up on GitHub, and I threw the link in the chatter feed for this session. And also this PowerPoint is up there as well as a PDF. So you can go to the chatter session for this and download both of those. Just to show you that hello world real quick. It's really simple, but what is cool is we can go in here and change this up a bit. So I'll jump into presentation mode on here. So right now I have this basic, the only difference from the previous example is that I'm not outputting a div here. I'm doing view and text. I'll explain that in a moment when I jump into React Native. But I made this hello props component. And I can change that to there. And I have some kind of syntax error. Live coding, always fun. No, I have to terminate my tag. So now it says hello Dreamforce. And then to demonstrate the counter real quick. It's a pretty simple counter here. We have the current initialized state that we set in the constructor. And I hit the increment, and it goes up. And I hit decrement, and it goes down. The last fundamental part of React, so it loads up here, is the idea of component lifecycle. You have this idea in Lightning Component Framework as well, where you have the render phase and the on-render and the re-render. With React, you get three core life cycles: is mounting, updating, and on-mounting. And then you have some lifecycle hooks that you're able to hook into as it goes through this. So like when a component is first mounting and getting initialized, you can hook into the constructor. The render method will fire through both mounting and updating. And then there's a component did mount, so that's where you typically do your data fetching. And component will on mount will be fired when it's taken out of the DOM. And so then it will fire the component will on mount, and then you can fire things that will garbage recycle, event listeners, and stuff like that. Just any kind of cleanup you need to do. Hi. Yeah. Okay, cool, awesome. Thank you. Switching it up. I don't have any more Big Trouble in Little China jokes. That was my only one.
That's not what I tried to do.
No? I'll just keep kind of talking about React and React Native. So we saw how React is targeting the DOM. And that's how React started out, is that it was targeting browser applications and making single-page applications within the browser. So a lot of the examples were using divs, H1s, stuff like that for the JSX. One of the things that Facebook realized is that you could abstract away the DOM out of how React was handling the view, and instead target more abstract things. So if you saw my React code at all, the React Native code, you saw that it had a view and text inside. That view component is actually an abstraction on top of the UI view on iOS and Android.view on Android. So they realized by abstracting these things out and targeting those instead of the DOM, you could target the mobile device instead of just the DOM. So you're targeting things like view, text, scroll view. It looks like we're back on. Thank you. Awesome. So I'll go back a second here to here. So we covered the lifecycle methods. So yeah, they realized they could target mobile applications. So you could target iOS and Android by abstracting these out. They provide a lot of different React components for the underlying native UI components. So view for that UI view and Android.view, text for displaying text. There's a camera roll component, so you can access the device's camera roll. The awesome thing about this is that it runs natively on the device and not in a web view like you would with Cordova and a hybrid type app. So just to go over a quick example of our Hello React Native component, you can see here we're doing view and text, and we're importing that from React Native. Now, React Native provides a lot of out-of-the-box components to build mobile applications. You have that view, images. A lot of these are pretty self-explanatory. You can collect user input from text input. Scroll view allows you to easily have a smooth scrolling experience if there's more elements within your view than is in the viewport of the device, so that you'll get the smooth scrolling. And then style sheet is very important. Now, we're still kind of dealing with a web development with JavaScript and using XML components to display stuff. So you might ask how I can style these components within the mobile application. What Salesforce or what Facebook has done is they have a style sheet, and that allows you to actually style the components with CSS style syntax within the mobile application. And I'll demonstrate that real fast. So I'll come in here. So we had this hello props that we changed. We'll actually jump into the hello props component here. So you can set inline styles just like you would with a browser component. So here on this view, we can do background color. So you can do that, and if I pop back in here and reload my application, you can see here that that changed. So now it's got a background of blue and a text color of white. And then where style sheets come into play is here. Down here I'm using the style sheet.create. So you can see if you're using just the inline style, it would get out of hand pretty quickly if you were using a lot of different style elements to something. What the style sheet create lets you do is create an object with different keys, and the keys act as like a grouping of different styles. So here you can see I have this key background container, and I'm collecting a bunch of different style elements underneath it. So instead of doing this, I can I'm calling it styles here. So I just call it by the name, and then the key. And if you notice, I'm actually using Flexbox here. It supports Flexbox. Yes. I know. Thank you. And now that we're using Flexbox, it's filling the entire container. So I hope you can see like how powerful this is. Like, people already know JavaScript, they know CSS. All of a sudden, people who know those two things can start building iOS and Android devices. All right, jump back into the presentation. There's a lot of other components that they provide, buttons. There's a lot of stuff to build like a business application. You can do that with a lot of the out-of-the-box components. There's switches, sliders to pick things. You have a picker to pick from a variety of values. There's flat lists, there's virtual lists, so you can show many items and it's virtualized so that you're only displaying what is currently there. Modal, and then they have a variety of iOS-specific APIs and Android APIs that they expose that you can access. Now, jumping into how all of this ties in with Salesforce. So the Salesforce Mobile SDK has been around for a couple of years now. It's had hook-ins for building Android apps with Java. It's had hook-ins for building Objective-C iOS apps. Now they've even extended it out further. This year they announced that partnership with Apple. But what it really is a collection of tools. It allows you to do enterprise identity and security better. It provides a lot of OAuth functionality, so you don't have to worry about doing that yourself. There's a SmartStore encrypted database. It's a non-relational database that's encrypted and secure, so you can store data on the mobile device without worrying about doing all that security yourself. So you can imagine trying to put a SQLite database and storing Salesforce data into that, and that's not secure, and that's not a good way to go. So they provide the SmartStore encrypted database for you. There's a SmartSink data framework. So one thing is that I'm not hooked up to the Wi-Fi right now, and I'm using the SmartStore database. What the SmartSink data framework does is it allows you to lose connection on your mobile device and still be able to make changes to your data from Salesforce. And it works upon this idea of sync down and sync up. So you sync down the data from Salesforce, and then you can sync back up, and you can have a variety of configurations in terms of how that syncing works. Like if you overwrite data on Salesforce, when you make changes on your device and the data has been changed on Salesforce's end, or if data has been changed on Salesforce's end, it overwrites your local device data. You can set all that up with the SmartSink data framework. And then it also provides a bunch of utility services for like push notifications and doing stuff like that. How this interacts with React Native is that the Salesforce Mobile SDK team has created this React Native Force library that exposes a bunch of different modules to expose that set of tools. So you have OAuth module. It provides three major methods. You get a get auth credentials, you can authenticate, and you can log out. A lot of these work off of success callbacks and error callbacks. So here is just a quick example where we're using one of the lifecycle methods. So when this component mounts, it will get the auth credentials and then do something with them if it's successful. If it fails, then it will try to authenticate and then do something with the credentials. Otherwise, we'll handle the error in some way. And then log out, you would want to do something more complicated than this, but this is just a button. It will log the user out after they've done authenticating. There's a network module that they provide. This plays into the authentication. So once you have the authentication, the network module serves as a wrapper around the REST API. So you can have easy access to the REST API with this network module. It's fairly similar in scope to like something like JS Force or the force.js library for hybrid apps that exist. So you get things like query, create, delete. Here's an example of using the query. I'm just providing it a SQL string. and then it will go out and execute this. And then in the callback, I can set the state of the component with the response records that I get back. You also have stuff to like describe layouts, describe the schema. They provide a SmartStore module. The way the SmartStore module works is the idea of soups. So you can think of a soup as like a database table. So you register a soup with a name, and you provide the fields that are in that soup. And then you do things like query the soup. You can upsert entries into the soup. And you can, the soup works very well with the SmartSink data framework. So you get that, the SmartSink module here. As I explained earlier, it works off the idea of sync down and sync up. So here's an example of a sync down where I'm getting the field list and creating a kind of, you can provide a SOQL type query, a social type query, or you can get the metadata down. And then what we're doing is we're syncing down, and we're targeting that account's soup that we created earlier. So this will pull the data down from Salesforce when we sync and put it into that account's soup. And we're overwriting any data. So on the sync down, if changes have been made on the mobile device, and on that sync, we'll actually overwrite the data on the mobile device. And then you can name this, the sync down and sync up targets. And then you can actually call a resync method that's kind of a helper. So you can just resync this named thing. So you don't have to constantly specify this configuration every time. So now that we got those basics of the Salesforce Mobile SDK out of the way, a little bit that will help you installing and configuring all this is some stuff that I learned. I think the latest version of Node is 9. It's greater than 9. It actually doesn't support that right now, so you'll have to downgrade your Node if you have the latest version. The current max version supported is 8.11. Provided some helper utilities here to help you get set up with Node 8.11. And this N utility will actually let you install whatever version of Node you want to be running in that context. So you can downgrade to Node 8.11 for this, and then re-upgrade later by running this command again. If you're doing iOS development, the current version of CocoaPods is 1.5. 1.4 is the current max supported version with this, so you can install CocoaPods 1.4. And then finally, you'll want to grab the Force React CLI from NPM. What the Force React CLI lets you do is it has two commands. It has create and create with template. It has these options that you can set up, so you can specify what platform you want to develop on, iOS or Android. You can do either or both. You specify your app name, the package name, the org name, and the directory you want to go in. If you don't specify all these up front, it will take you through a little wizard. The create with template is pretty similar, except you specify a template URI. This can be a repo that you have, and you'll specify a template.js file in there, and that will specify how the template gets set up. They have two existing templates out there. I utilize one of them for the sample application. It's the SmartSink Explorer, but you can create your own template and have that set up with every new application that you build. So, we all know that Android uses Java or Kotlin, and iOS apps use Objective-C or Swift. So how are we developing with just JavaScript? What Facebook has provided on their end with React Native is this view layer where they're compiling the JavaScript and displaying that natively on the device. Your core business logic lives in JavaScript, and it also drives the user interface. The only time you need to write any Java code or Objective-C or Swift code is when you need SDK functionality that isn't already exposed by React Native and isn't exposed by anything open source that exists and isn't exposed by Salesforce Mobile SDK because they've already written those bridges for you. The bridges are pretty simple to write. We had to write one at my former company because we wrote an application for a scanner. The scanner device had its own SDK, so when you scanned an item, it would scan a barcode, it would go into the device. We needed access to that data that was scanned in. So the bridge is really just a JavaScript method that hooks into a either Java method or Objective-C Swift method, and then returns data. So the bridges aren't very complicated to write. They're pretty simple. You're really just passing data from one programming language back into JavaScript. There's a lot of open source stuff. One thing we needed was to play sound on the device. There's an open source library that lets you do React Native sound. There's a lot of stuff out there. So it's a pretty wide ecosystem. Want to go quick into like moving between screens. There's a lot of different libraries out there. React Navigation is one of the most popular ones. I utilize that in the demo. It provides a lot of different types of navigation. Stack navigation is where you have different screens and they're layered on top of each other. Tab navigation should be familiar to anyone who uses a modern browser. And then drawer navigation is that little hamburger menu where you can open it up. All of these work pretty similar in terms of how you set up the routes. The difference is like in the configuration with tab, you specify what tabs exist, how they're set up. Drawer navigation, you set up like what the drawer width is when you open the hamburger menu. It's pretty powerful. It lets you pass props to the next screen so that you can initialize screens as you move through the application. Here's a quick example of using the stack navigator. So we import this create stack navigator from React Navigation. We import 2 React components, and then we just set up these routes, home and contact, with which screen, which is the React component they specify. And then when we want to navigate to one of them, just an example of like using a button to do so. When you set that component up like that, it will actually pass this navigation as props down through everything you set up in there. So then you can navigate to that route. So here we're navigating to the contact and we're passing a contact to that screen. And then finally, one of my favorite things about React Native is the debugging capability. So it actually natively out of the box uses Chrome console debugging, so this should be super familiar to anyone who has been doing any kind of browser development for a while. So I'll jump into here real quick and show this off. There's this developer menu. You can access this by, on the iOS simulator, it's very easy. It's just a shortcut key. If you actually hook up your device by USB or by remote debugging, you can set it up by IP address. You can do a shake gesture and it will pop up. But you can see you have a bunch of different dev options here. One of them is debug JS remotely. So I'm setting that up, and then I have my Chrome set up. So then I can actually jump into the JS code that is running on the device. And so if I jump into the search screen component, I can set up a breakpoint here and a breakpoint here. And then if I jump in, and you can see my breakpoint fires. I'm not interested in debugging it yet. But so if something was going wrong and this searching wasn't working correctly, I can type in T. You can see my breakpoint fires. I can come in here and start inspecting like what the query was. It was T. And then I can even advance into the callback and see what the SmartStore is returning here. So I can actually see it's returning this data. So it's really powerful in terms of how you can like debug your application as it's running in a familiar format to anyone who's done any mobile dev work or web dev work. Finally, I'll get into testing a little bit. I'll fly through this a little bit. Facebook has released this testing library called Jest. It operates a little differently. You can still do a lot of like behavior-driven expect stuff, but it also has this idea of snapshots. The way snapshots work is it generates a JSON file of what the expected output of the React Native component is. And then once that snapshot is generated, whenever you run tests, if something changes to that expected output, then it will fail the test. Now, obviously, as you're working on a component, you'll expect things to change, so you're actually able to overwrite the snapshot with the new expected output. It's a little different way of testing. Some people like it, some people don't. You can still do old school testing the methods, but that's a little more complicated. You have to set up like Enzyme, which is a library that Airbnb has built to do this. It's pretty cool though. Like, it'll show you when it fails. It'll show you what the diff is in terms of the snapshot. So like, if I ran it now that I've changed that hello world component, it would say expected hello world. Now it sees hello Dreamforce and it sees different styling. The default configuration for Jest is to have this this tests folder and snapshots folder are tested in here. That's just the default configuration. I'll run all the tests that are in this folder. You can set it up differently, but then you have to configure it differently. And I like writing functionality, not configuring things. And then a quick example of what a test looks like that's doing a snapshot test. We're importing a React component. We're importing this React test renderer, and we're exporting the renderer output to JSON and expecting that to match the snapshot. So the first time you run Jest on this, it will generate the snapshot. I think that's one thing that is hard to come across the first time, is that the first time all your tests will pass if you're just doing snapshot tests. But then as you develop on from there, then you'll start to be able to match against the expected output. So a summary of what you've learned today. React Native allows you to create cross-platform mobile applications. It takes a common core of what's on iOS and Android and allows you to build on that. And it allows you to do it all in JavaScript. The applications are rendered natively on the device and not in a web view. So it's not in a web view like you would with a Cordova or another hybrid application. And I hope I've demonstrated that you have a rich toolkit here with, in terms of the open source ecosystem, the debugging you get, the snapshot testing with Jest, and just everything that's provided with this toolkit in the Salesforce Mobile SDK. So I have a list of resources here where you can find out more. I have all the documentation for everything I've gone over. There's this awesome React Native, which is a really cool resource. It just has compiled like all the different React Native resources that are out there. And you can spend probably a couple days going through everything that provides. And then the example code that is running the application I demonstrated is here at this repo here. My username in Dreamforce 18, MadMax 983, because I like 80s movies. Then finally, tomorrow is the developer keynote at 1 p.m., so we'd love for you to come there and check out everything new. And I'd like to thank you all. Thank you for coming. If you have any questions, there's a mic there.